Question number 3 from the June 2019 AQA higher tier physics combined science paper. This question is on the motions topic. Some quantities are scalars and some are vectors. Which of the following quantities are scalar quantities? So you have displacement, distance, force, speed, and velocity. Out of these, you need to tick two boxes. Displacement is a vector quantity. Distance is a scalar quantity. Force is a vector quantity because it has direction. Speed is a scalar. Velocity is also a vector. So distance and speed. Question 3.2. Give the difference between a vector quantity and a scalar quantity. Remember that vector quantities have both size or magnitude and direction. Scalars only have a magnitude but no direction. The difference between both of them are they both have magnitude but only vector has direction, or you could say scalar does not have a direction. Next question. Bumper cars are a fairground ride and are designed to bump into each other. Figure 5 shows two bumper cars moving towards each other. The momentum of each bumper car is shown by an arrow. So you have momentum from left to right of the boy, and the girl is from right to left. They're in opposite directions. Remember, momentum is a vector quantity, so the direction matters. So if I say the boy has positive momentum, the girl would have negative momentum to indicate the direction. Give two factors that affect the momentum of each bumper car. Now, when you look at the equation for momentum, momentum equals mass multiplied by the velocity. So, you could say mass and the velocity, but you could also say the friction or the power of the motor as well. And you could also say the weight, direction or speed, air resistance or the drag, but I would simply stick to the first 2 points, mass and velocity. Question 3.4. The bumper cars crash into each other and stop. Explain why both bumper cars stop after the crash. So, if before they crash, they have a momentum, so you can see they're actually moving. Total momentum is 0. If they stop, that means the total momentum is 0. So they have cancelled out each other. So total momentum is 0 after the collision because the bumper cars are stationary or have stopped. Because the momentum of each car before the collision was equal in magnitude and opposite in direction. So the total momentum of the bumper cars was 0 before the collision, and the momentum is now conserved. Another way of writing the answer would be to say total momentum is 0 after the collision because the bumper cars are stationary. That's one mark. The second point would be to say because the momentum of each car before the collision are equal in magnitude and opposite in direction, both cars exert an equal and opposite force on each other for equal periods of time. So the car accelerates in opposite directions. I'll still stick with the first answer. That brings us to the end of this question. I'll see you in the next video.